All right, welcome back. We're getting near the end. What are we doing today? We're gonna do 9.2 and gloss over 9.3 kind of thing. And then we're doing chapter 10. Chapter 10 is gonna take the longest. But we should be done with chapter 9 in less than an hour, hopefully like 45 minutes for all of it. So 9.1, we were doing sample proportions. We were finding confidence intervals. We were doing confidence intervals, and we did it on proportions. So we had U of P hat was P, and sigma P hat was square root of P times 1 minus P over N. That's what we used for yesterday. For population mean, we normally do mu of X equals the mean, and the standard deviation, we saw this in chapter 8, was the standard deviation of the population over the square root of N. But, so what is this actually telling us? To estimate the mean, and standard deviation, we have to use population information. Because that was mu of population as well. But if we had population info, we would not be doing this shit. Fucking hair's a different color. Fucking. You went home, mouth off to your mom, she made you fucking dye your hair?
Nah, actually, I've been wanting to change it back for a long time. And so my mom finally bought the dye. And
She fuck you up?
I mean,
No, I mean like when you said, "Mom, you wasting my time," did you keep?
no, she was just like, are you serious? And I was like, no, I'm just fucking with you. But obviously, I had to say that. But she thought it was funny.
So, I think that agreed. People are still writing. I'll slow my ass down. Okay, so since we don't have that information, what we're going to use is something called student's t-distribution. There's this guy named Gossett in the 1900s. He worked for Guinness Brewery, and he was working on doing this mean standard deviation shit for beer. He was working on beer. And he was running into this problem where he didn't have this fucking population standard deviation stuff. And so he's like, what can I do? And so he just started doing example after example after example, collecting data, came up with this fucking shitload of data, came up with a formula to use. And then like Guinness didn't want him publishing under his own name, so he went by the name student. It has nothing to do with teacher student, I don't think. But he goes by, he published under the pseudonym student, and the formula for T is X bar minus mu all over S divided by the square root of n. There's not supposed to be a bar over that, just a t. Now, we won't use that.
Wait, what is T again?
T is like standard deviation here.
Does it have another name or is it just standard deviation?
It's just T. It goes by T. And actually, it's like the mean. It's like the normal, the T distribution is like the normal distribution. So it's a distribution, but it's slightly different. And we're gonna list the differences in a second.
Does it matter if it's a lowercase t or uppercase t?
It's usually a lowercase t when it's in use. They give it a capital T when we're talking about distribution. You're not going to calculate this by hand. If you need to find t, and one of the homework problems you can do stats, calculators, t. In fact, in this morning class at 9.2, the last like 20 minutes of their video is on 9.2. I did problems 1, 2, and 7 from the homework. You'll see it up as Math 321 content this evening when I get home. I'll load it up. You can look and see how we did problems 1, 2, and 7. Number 1 did T. Number 2 did something else. Number 3 was on criteria. We're going to do another one here, like problem 5 or 6. But you can see how that's used there. But that's what you'll do. You won't use that formula. This is for doing this shit by hand. Chapter 9 onward is filled with fucking red herring shit. You like go to do the homework and all the way you're like, click on this blue link for this table. And like most of the, very few problems should you ever click on the fucking link. It's how to do it by hand. There's only one of them that I noticed, and I do it in the video. I think it's 9.2. They're giving you information that was from chapter 4. They show you a box plot. They give you the correlation coefficient. They're giving you information there that you actually need from the link. But the rest of them are distribution tables, and we're not doing shit like that by hand. We're not going to calculate T by hand. You're going to do a calculator. What you need to use this calculator are the degrees of freedom. Is what's needed. And this, it's abbreviated, it says DF in the program, and it's actually equal to n minus 1. So if you know the sample size, you can find the degrees of freedom real quick.
Which one of those stat crunch is T?
Yeah, stats, calculators, T.
Degrees of freedom. That equals or less than?
Equals.
And then
Equals DF stands for degrees of freedom. It shows up on the T. That's what the thing they asked you for.
oh, that's what it asks you for?
Yeah, I'll show it to you later. We won't do a problem with it, but I'll bring it up and show you. I want to get through the rules of T, and then we'll do a problem from the homework for this, and I think that'll like get you what you need to know. All right, so
Can I see? So it equals n minus 1, or is it?
n minus 1
Like it equals it, or is it?
equals. Okay. So T's distribution, properties of the T distribution. It is symmetrical and bell-shaped. And centered at mu equals 0. Just like our normal distribution is, our standard normal distribution. This property kind of leads to B, where the area on the left equals the area on the right, which is 50%. That's from the symmetry. Just like the normal distribution, it is, T looks different for different sample sizes. That's actually true for the normal distribution too. The one we know, we have a standard distribution of 1, but the sample size affects the standard distribution. And like, so smaller, taller, wider, fatter, but it's still bell shaped. This has got a lot of things in common with the normal bell curve, which is handy. And just like the normal bell curve, the tails approach but never touch the axis. We'll call it the x-axis. Things that are different. The tails are longer for T than for Z. Z is our normal distribution. What this kind of means is for the same standard deviation, T has more area under the curve than Z. Goes out a little bit farther. And as n increases, our sample size increases, our sample standard deviation, which is S, approaches the population deviation. Sample approaches population standard deviation. And this causes T to look more like Z. T looks more like Z. Which means when n gets high enough, it's just as good as the normal distribution, which is good. On the next page, we'll talk about what n being high enough means.
What's the differences between these two lists? The blue list was, you said something was different when you started writing it red.
The tails, like the bell curve, the tails are like higher further out than Z, the normal distribution, which it causes the area to go change. This is, I don't know how much you're gonna actually need this information, to be honest. Now that I think about it, I don't know that there's any question that ever asked this. It's just more of the idea to show the main gist of this is T looks a shitload like the normal distribution. And when it boils down to is n gets big enough, it's good enough to be the normal distribution. So we can use it for our normal distribution. What does n big enough mean? Well, n big enough means this. If n is greater than or equal to 30, we have a bell shape, and it's like just like a normal distribution. Good to go. Out the door, good to go. If n is less than 30 is where you gotta do some work. We need the QQ plot to look, it's something we did in chapter 4. It needs to be approximately linear. And the way we showed that is we check the correlation coefficient. Was that greater than the critical value? So this is stuff in chapter 4. I want to say problem number 2 and 9.2 does it, and it will be in the video that is going to be up tonight. If you want to see it worked out, like walking through as a reminder for chapter 4, you can see what we did again. I won't do it again here for the interest of time. So that's one thing we got to check. And the other thing you got to check is the box plot has no outliers. If both of those are true, you're also good enough to go. Then good to go for normal. If not, we probably can't use T. Which is a solvable thing if you're out doing fucking surveys. All you gotta do is get n to be bigger than 30 and you're good. So like this is something you can avoid if you take enough observations or samples. Is ready for a little bit more?
We're kind of confused. Like, for any, like, how will like the problem look? Kind of like it is.
Problem number 2 on the homework. And you can see the video on how to walk through it later on. Most of the time, we're gonna assume this is good to go. Like, all you gotta do is you have your sample size bigger than 30, and this is a moot point. It doesn't really matter. You don't need to worry about all this shit. So, It's a plot comparing score values versus the z-scores. It's something we did in chapter 4.
Okay.
Which was last Wednesday? Something like that. I like the name because QQ, that's some shit you say to someone in like an online role-playing game, like an MMORPG. It's designed to look like two eyes with little drops coming out. It's like, quit fucking crying, you noob. Say QQ to them. That's some old slang. I don't know if they still do it. That's some gamer talk. All right. So, like, what's this going to do for us? So, just as 9.1, 9.2, in both of these, we went stats. What we did in 9.1 is we clicked on proportion stats. But for 9.2, we're clicking on, I don't want black, I want red. For proportion stats, we did that, or we're doing t-stats for the mean. So this will be for the mean, and proportion stats clearly says proportion in it. You already know. And you saw the following on each of them. Once you got past that selection, you'll see on t-stats, but you've already seen this for proportion stats. We had the option of 1 sample, and we still had the option of 2 samples. Then we had with data, with summary, and we did that power sample size thing yesterday. Those are all on both the proportion stats and t-stats. T-stats has one other column here, and this one, it's paired. This is only in t-stats, and it's going to be chapter 11.
Paired is with data with summary, that's under that.
Yeah, it's on the same tier as 1 sample and 2 sample. Paired is only on t-stats, and it doesn't have like these other options because it requires data. You cannot have paired data without having the data listed. You can't summarize that shit. We'll see that in chapter 11. On both of these, you can do confidence intervals. There's a radio button for confidence intervals and for hypothesis tests. Confidence intervals is what we're doing in chapter 9. The hypothesis tests for those 2 categories are going to be chapter 10 and 11. And 12? Maybe 12? I don't know, maybe 12. I don't remember what's in what. I know 13 isn't. 13's definitely not on the list. It has its own. I don't think chapter 12 does either. The 10 and 11 both are, like, I think chapter 10 is 1 sample. Chapter 11 is the 2 sample shit. And we're going to be doing hypothesis tests for those. But these are the menus you use for almost everything from here on out. Chapter 12 and 13 will have different ones, but there's only 3 sections total: 12.1, 12.2, and 13.1. We will knock all of those out on Thursday. For the proportion stats, as a reminder, it asks you for number of successes and number of observations. That was X and that was N. What the t-stats is going to ask from you is It will ask for the sample mean, the sample standard deviation, and the sample size. Those are the three things you need there. And let me pause, I've said a lot. Like literally, like most of it, like today and tomorrow, and even what we did for chapter 9 yesterday is all within the, all in this, covered in this one page. Like literally the commands you're gonna use. The same way we did power sample size yesterday when we needed to find n, the same thing applies for the mean. If you need to find the sample size for the mean, you can do that power sample size, shit like that. Most of the problems give you all of this. This is for the summary, I should say. This is for the summary. If you have the data, you'll just tell what column your data is in. We'll see that today. If it doesn't give you this, like you'll know the sample size. It's got to tell you the sample size. If it doesn't give you this, well, you probably have the data, and so you won't need this. You have the data and don't need it. Let's find a good problem to go over with you in chapter 9.2. If they ask you for it, if you have the data, they still ask you for the mean and the standard deviation. You guys have actually done this. Stats, summary stats, columns. You can find the mean and standard deviation for data. Remember back in chapter 3 or whatever? We had the data and it said find the mean and standard deviation. And you just clicked on it. And so as a reminder, our old tools are still good.
So you can still use that row.
Yeah. Looking for a good problem to do with this. Maybe 5. gonna start problem number 5 with you guys. Just so you can see how it works. Problem number 5 is one of those that has 3 or 4 parts. Each part asks you to enter a couple things, and the idea is you're comparing them. So let's look at number 5 real quick. So number 5 says we do a simple random sample of size n drawn from a population that's normally distributed. So they tell us it's normally distributed. We don't need to do any other work to make sure that it is. None of that QQ plot shit, none of that. It says the sample mean is found to be, where is it? 105, and the standard deviation is 10. Then it says construct a 98% confidence interval with n equals 16. That's A. Notice what changes between A and B. The percentage stays the same, but the sample size changes to 12. They're going to ask you to go, what happens between the difference between how did going from n equals 16 to n equals 12 affect your outcome? Then for C, they go back to 16, so you're still doing sample size 16, but they change the confidence interval to 90%. You're going to see a couple things happen. So problem number 5, I have X bar equals 105, I have S equals 10, and A gives me 98% with n equals 16. B gives me 98% with n equals 12. And C gives me 90% with n equals 16 again. I'll just show you how to get A real quick. But I want to point out to you what it means what's going to happen. And I'm going to draw a bell curve real quick to show it. I'm just going to do some quick things on the bottom. Here's our mean, here's our upper bound, and here's our lower bound. And they're going to ask you shit about the error and stuff like that. So remember, that's the error. As your confidence percentages go up, LB and UB move away from the mean. Like they go like this, which means your error increases. So a basic way of saying that is as percent goes up, error goes up.
Is 90% n equals 16?
Yeah. Then you're going to find also that as n increases, the lower bound and upper bound move closer to mu. So they'll go like this. They'll go inward. which means the error gets smaller. So as n goes up, e goes down. Those are the two big relationships you're going to notice. And it's actually question number 7 asks you shit like this. And it works true the other way. If n goes down, e goes up. That's what this problem is going to lead you to find when you do these comparisons. So be looking for it. But we're going to walk through doing the StatCrunch work in a second, just so you see where you get the values. Okay. So we have our mean, we have our information we're going to need. I'm going to go to Get More Help, StatCrunch. And we're going to do stats, T-stats, one sample with summary. And you'll see we've got one sample, two sample. They both say with data with summary. If we look over at proportion stats, one sample has all the same shit, two sample has all the same shit. The only thing that's difference between these two is paired doesn't have anything like that. Paired is something we're going to do in chapter 11. But for now, we're doing T-stats, one sample with summary.
Always with the summary?
What?
Are we always going to use the summary?
No. If they give you data, like a table of numbers, you got to use the data. But they'll give you a means to copy it over to StatCrunch, and then you could just tell it what column your data's in. So they give us 105, and they give us 10. And the sample size started out at 16. And we're going to click on confidence interval. And they started out at 98%. And you're looking for the lower limit and upper limit. So that's what you'll enter. I'm pretty sure that's what they're asking. Let's tab over and look. Yeah, they want the lower bound and upper bound. Then they'll ask you to do the same thing for changing this to 12. This is 98.5 and 111.5. When I change the sample size to 12, now 98.5 is 97.1, which is lower, which means like on that bell curve thing, it's further to the left. And the upper limit went from 111.5 up to 112.8, which means it's higher or further to the right. So we had 98.5 and 111.5. And now this is 97.2 and 112.8. So if this is like 98.5, 97.2 is over here. And if this is 111.5, 112.8 is over here. So you'll notice as n went down, this was n equals 16, this was n equals 12. N went down, my error gets larger. You guys see that? N went from 16 to 12, and our arrow went from this length, the red length, to the green length. Yeah. So like the percentage didn't change, our confidence interval. N equals 16 was right here, was the two middle values. N equals 16. So as n goes down, it went down in value. My error was the red line, it now gets longer and it becomes the green line. So and I set it down here, as n goes down, or as n goes up, e goes down, the reciprocal of that is as n goes down, e goes up. Your error goes up. We'll see the same with this here. If the percentage goes down, the error goes down. You'll see that in part C. But the part I wanted to show you was literally what we had to enter. You need to enter sample mean, you had to enter sample standard deviation, and you need to enter sample size. Remember how we had problems yesterday where it had like, it gave you the upper bound and lower bound and it said to find the mean in the middle? You're gonna do the same thing. There's questions like that for this one here in 9.2 as well. Basically, everything you did in 9.1, you're gonna do in 9.2. A lot of it's identical the reasoning. The only difference is when you need to use proportion stats versus t-stats. So, what 9.3 is going to push on you is like, how do I know which to use? Do I use proportion stats or t-stats? I'm glossing over this pretty quickly because like some of it's pretty obvious. Well, in some cases, it will say proportion or mean. It'll say proportion or sample mean. That's the obvious, like the gimme.
Wait, what's 9.3 again? Like-
This is like what the header I use. Do I use, which one do I use?
Oh, it's just.
There's nothing new. It's just like, if you're reading a word problem, how do I pick? Does that make sense? Because 9.1, you know when you're doing 9.1, it's all proportion shit. When you're doing 9.2, you know it's all stat shit. Well, when you're like doing like problems in like a test or something, you don't know which is which. It's not labeled for you, so what do you look for? If it says proportion or sample mean, it's kind of like a dead giveaway. But if it doesn't, you can look for other shit like this. You might see qualitative outcomes. Like we might have yes or no. This is where you get like the whole, are you a Republican or Democrat? Pepsi versus Coke, shit like that. These aren't numbers. This shit can even fall under numbers. Less than 21 versus greater than or equal to 21, like are you of drinking age? That has numbers in it, but the answer is qualitative. And this is like part of the population answers one way, part of the population answers the other. Some the other.
Let's say, like, let's say rep or population.
Here?
Or above that, which says
Rep,
rep.
like Republican.
Oh, okay.
Republican / Democrat. I shorthanded that. You're right, that does look like a P though, like with a tail on it. Let me make it sure that it looks a little bit more like an R. All of this stuff is definitely proportion. Qualitative is going to be proportion. Because there's no numbers in it, so there's no way to find a mean. No way for a mean standard deviation in the sample itself. This is where you'll have to check n times p times 1 minus p. Is that greater than or equal to 10? And you'll need to do is little n less than 5% of big N. So sample size less than 5% of the population.
Answers one way and one.
Part of the population answers one way. They like, some say Coke, some say Pepsi. I'll pause. I'm clearly way ahead. Not giving you enough time to write. The other thing you can see is quantitative data. Like a table of numbers and shit. A table of numbers or column of numbers. They might actually just give you X bar and S, the sample mean and standard deviation. It might even give you the population mean. This is clearly a means thing, so this is going to get you your t-stats. And just like proportion stats had some checks, t-stats has some checks. If n is greater than or equal to 30, this is like an auto win. You're automatically normal. Well, when you kiss his potato.
Wow.
What's that say after n is greater than or less than or equal to 30?
Auto win. Automatic win. That's some David slang right there. Auto win. You automatically fit the criteria. You don't need to do any work. If n is greater than 30, you're done. No checks like you have to do with proportion stats, nothing to do. Getting n over 30, you would think isn't too hard, but like some circumstances, like n is 12 is a high number. If n is less than 30, you gotta check for no outliers on the box plot.
You have an arrow to normal under auto win. Are you referring to normal distribution?
Yeah, it's a normal distribution. Then if n is less than 30, we want no outliers on the box plot. And we want the correlation coefficient to be greater than the critical value. This is shit we did in chapter 4. Chapter 4 homework. That's it for chapter 9. I'm gonna hit stop record there, so we'll have 2 videos, one for chapter 9, one for chapter 10.